So we're going to continue with gas laws. We're going to start looking at temperature as one of the factors that changes the volume and pressure in a gas. So when we did Boyle's law, we just dealt with volume and pressure. We didn't talk about temperature, okay? Now we're going to talk about temperature. And in order to talk about temperature, we have to talk about the Kelvin temperature scale. Okay, there are no negative numbers in the Kelvin scale. Kelvin starts at what they call absolute zero, when everything is frozen. And that temperature is negative 273 Celsius. So all we have to do is, if we have the Celsius temperature converted to Kelvin, is add 273 to it. So but whenever we work with gases, we have to work with the Kelvin scale. So if you get the temperature, if it says 20 degrees Celsius, just add 273 to it. That's all you have to do. And here's an example talking about gases and their volume as they're cooled. Okay, here it's cooled to negative 273. You guys, that would be absolute zero. Absolute zero is when everything's frozen. We've never got to that temperature, even though a few times in the winter it feels like we're close. But this is the temperature at which nothing is moving anymore, negative 273 Celsius. So again, when we deal with gases, because of their wide range, we use the Kelvin scale. And that's actually the scale that you're supposed to use in the metric system. And it's, like I said, it's easy to convert. All you have to do is add 273 to your Celsius temperature. Okay, and there you can see. The temperature is referred to as absolute zero. That's where everything stops moving, okay? Gas laws, when you do gas laws, if it has temperature involved, you have to use the Kelvin scale. And again, it's really easy. Just take your Celsius temperature and add 273. And that's how you get your Kelvin, okay? It's pretty simple. Okay, so the next guy that worked with gases and came up with laws is Charles. Okay, Sir Charles. All right, and not Sir Charles Barkley. Okay. Anyway, Charles worked a lot with gases, and honestly, from what I've heard, he didn't really do the work. He had an assistant do all the work because he had a lot of money, you know, so he paid people to work for him. So I think he gets credit for stuff he didn't do. Now I need to go back to the notes. Sorry. Anyway, the volume of a fixed quantity of gas is directly proportional to absolute temperature of the gas at constant pressure. So now we're not dealing with the pressure. Okay, that's going to stay the same. What we're changing is the volume and the temperature. And these two are directly proportional. In other words, when one increases, the other one increases. If you look at the little diagram here, okay, if I'm going to increase the pressure of this little piston, okay, well, you got these particles in here. All right, if I heat it up, and this is what happens in your engine, heat it up. Now the particles are moving faster, they exert more force, and boom, up goes your piston. Okay, and then the temperature goes down a little bit, then this falls down. And then when it gets heated up, back up again. And again, think of balloons. I'm always on the balloons. But if you've ever bought a balloon like those big Mylar balloons in the wintertime, you buy it in the store, it's all poofed up, and you take it outside, and all of a sudden it's all shrink. It shrivels up. But then you bring it back in your house again, and poof, it's back the way it was again. When you cool it off, the particles inside don't move as fast, so it shrinks. So you decrease the temperature, you decrease the volume. Once you take it in the warm air again, the temperature goes up, the volume goes up, okay? So Charles' law is directly. So when one increases, the other increases. When one decreases, the other one decreases, okay? Here's the form for it. The volume of the first one divided by the temperature of the first one equals the volume of the second divided by the temperature. And you can use that form to, and when you're looking for V2, then I would just take T2 and put it over here. If whichever one you're looking for, you can just do manipulation of this formula to find your answer. Okay. All right. So here we have 3 liters of hydrogen gas. It's at negative 15. So the first thing I would do is I would have to change negative 15 to Kelvin. So I'd have to add 273 to it. So what would that be? 258. Okay. So you've got to change the temperatures. Okay, so it's at again, it's at 273, and now we warm it up to 27. So again, we got to add, that would be 300. We got to change these temperatures to Kelvin. Okay, so now we want to figure out, and we're going to keep the pressure constant because we're not doing with Boyle's law, we're doing with Charles' law. Charles' law deals with temperature. Okay, so what do we have here? We have this first volume, we have the first temperature, and we have the second temperature, and we're going to try to find this volume. So basically, if I take T2 times V1 divided by T1, I'll get V2. Okay, so we got the numbers. And again, like I said, we have to change these to Kelvin. So if we take 273, we add 273 to minus 15, we get 258. We add 273 to 27, and we get 300. So there's our Kelvin temperatures. So I'm going to go 3 times 27 divided by, I mean, not 27, sorry, 300, you guys. So, because if I fill these in, again, if I take V1 times T2, again, I'm going to divide both sides by it. So T2 will be up here. V1 times T2 divided by T1, I'm going to get my answer. So I'm going to take 3 times 300 and divide by 258. Okay? So again, 3 times 300 divided by 258, and then I'll get my answer. Okay, and it's 3.5 liters, sorry, I cut you off there. Okay, that's Charles' law, all right? So here's another one. We have a gas has a volume of 3 at 10 degrees. Again, that would be 283 Kelvin. What is the temperature of the gas if it expands to 6? Okay, so we're going to try to find T sub 2. Okay, so now we got to do a little bit different. But again, what we have to do is we reverse these two. Okay, so you have to manipulate your formula. Okay, we're trying to find this guy right here. Come on, mouse right here. So I can switch these two and bring T sub 1. So if I take V sub 2 times T sub 1 divided by V sub 1, or in other words, the second volume times the first temperature, and then I divide by the first volume, I'll get my new answer. I'm going to do this before it shows it, make sure I'm doing it right. Okay, so I am going to take the volume 6 times, where am I at here? The temperature 283, and then I'm going to divide by 3. So I get 566. We'll see if I'm right, huh? Okay, so again, I got to manipulate this formula. T sub 1 times V sub 2 divided by. So you just plug in the numbers. 566. Hey, I did it right. Okay. Again, here's your first temperature. And again, it has to be in Kelvin. So, and then your volume. So again, you're just going to use this formula and you need to manipulate it so that you can find the variable you're looking for. Okay. All right. So here's another one. Let's see. We have 3. Now this one already put it in Kelvin for us. That's nice. So we got our 2 temperatures and we need to find our new volume. Okay, there's the answer. But again, we're looking for V2. So if you use that formula, V1 over T1 equals V2 over T2, you're going to have to manipulate your formulas. Okay, so the first volume times the second temperature divided by the first temperature will give you your answer. Oh, I forgot to times the temperature, sorry. Okay, that's where the 427. Okay, so I'm taking my volume 1, times my second temperature, 2666, and then I divide by my first temperature, 321, and that's where you get it. So again, you just have to plug in the numbers for that formula. Okay. All right, now they have combination laws. Okay, so Boyles and Charles. Boyles deals with pressure and volume. Charles deals with temperature and volume. Okay, well, we should be able to combine them as well. Okay, so if I have pressure, volume, and temperature, if you look, it combines because Boyle's law was P1, V1 equals P2, V2. And Charles' law was V1 over T1 equals V2 over T2. So you can actually combine them. So this is combined law if you're looking at pressure, temperature, and volume. And again, you just plug in the numbers and look for your answer. Okay, so this is the combined gas law. It's combined of Boyles and Charles. Okay, the volume of a fixed quantity of gas depends on the temperature and the pressure. Okay, so it's hard not to figure out the volume of the gas without, working with the temperature and the pressure. And again, those are the things. And the other thing we talked about, one more thing, is the amount of gas, and we'll do that in a minute too. We have something called the ideal gas law. So those are the 4 variables: pressure, volume, temperature, and amount of gas. Okay, when we talk about standard temperature and pressure, because sometimes they'll say a gas is at standard temperature and pressure, what that means is it's at 273 is the temperature and 1 atmosphere. Okay, standard temperature and pressure is 273, and you don't have to do 0.515, you guys. That's the exact, but I'm okay with you just using 273. And atmospheres, standard pressure is either 1 atmosphere or 760 torr. They equal each other. Okay, and most of the time they use 1 atmosphere. Okay, okay, so we have a sample of gas. It's at 125 milliliters at STP, standard temperature and pressure. So that would be 273 and 1, or they're doing torr, so 760 torr. You got to look what else they have there. What is the volume of the gas at 65 degrees Celsius? Oh, sure, going to make us find change our temperature from 65. We got to change it to Kelvin, and then we got our torr. Okay, so we have here we have the volume, and we have the pressure because it's 760 torr, and we have the temperature, 273. Over here, we have the temperature once we switch it to Kelvin, and we have the pressure, 320, so we got to find V. So basically, we're going to take the T sub 2 and put it over here, and the P sub 2 and put it down here. And then I can isolate my V sub 2. Okay, so those are all the numbers. And again, we got to change this temperature. Okay, so if it's at STP, it's either 1 atmosphere or 760 torr, they equal each other, and the temperature is 273. Okay, and here we figured our temperature. We took 65 plus 273. So we got all our numbers. We just plug them in. Okay, and I'm going to be in the way, I'm sorry, but it's 0.368 liters. And again, it's just taking your formula and manipulating it until you get the variable that you're looking for. Okay, so yeah, we still got time. Combined gas law problem. What is the volume? Again, STP for a gas. So we've got volume, we've got pressure, we've got temperature. We're looking for a new volume. What is the volume? Okay, so we're looking for V sub 1. We know P sub 1, the pressure is 760. We know the temperature is 273. Over here, we know the pressure is 616. We know the volume is 162. And we know the temperature is 273 plus 42. Okay, which is 315. Okay, so we got our numbers. We just plug them in. Okay, so P sub 1 is 616. Okay, volume 1, well, it's, let's see, what's the volume at STP that occupies? Okay, our volume 1 is 1.62, and our temperature, our second temperature, okay, T sub 1 is 273. And then again, our first temperature is 315, and our second pressure is 760. So just multiply and divide, and you'll get your answer. Again, plug in your numbers. And the answer is, I covered it up again, 1.14 liters. And again, it's just a matter of simple plugging in the formulas, okay? All right, here's a combined. Okay, we have a balloon, it's filled with 266 liters, so that's V1. And it's measured at 38, so 38, because we'd have to change that to Kelvin. And we have our pressure. So we have volume, pressure, and we have temperature. And what will the volume be? Okay, so we're looking for V sub 2. When the temperature is lowered to minus 76, ooh, that's quite a drop. So again, we take 273 minus that number and the pressure. Okay, and here we'll show you. Okay, so V sub 2, we're looking for volume. You're going to take the first volume times the first pressure times the second temperature, divided by the first pressure, or the second pressure, excuse me, and the first temperature. But again, we have to switch them all to Kelvin. So 38 is temperature 1. 38 plus 273, that's where the 311 comes from. The 197 is minus, 273 minus 76, because it's pretty chilly. Okay? And again, multiply, divide, and you get 299 liters. Okay? Again, sorry, I'm covering them up. When I put this in, I promise I'll put it in without. So we're almost done. What do we got in the next? Okay, we'll hit ideal law next time, and we'll probably finish up the notes next chapter. Okay, so this time we did Boyle's law and combined law.